So a big welcome to everyone who's new. We hope you have fun today. We are on lesson 2 of number patterns. So we are just going to keep on moving through them today. All right, let's get going. So Tuesday, we spoke about some special number patterns. Can people tell me what some of the special ones were? So what the names were of some of the unique number patterns we spoke about on Tuesday?
Fibonacci.
So close, yes. Fibonacci, the Fibonacci number sequence. How did the Fibonacci number sequence go? What were those numbers? Does anyone remember the numbers of the Fibonacci number sequence? Oh, these are good things coming in the chat.
It was
yeah,
minusing like the two, like turn the second one and the first one and seeing the constant difference.
Okay, so it was adding those two together. So that was on a close work though. Okay, so Fibonacci, I'm just going to write fib for the moment. Fibonacci went 1, 1, 2, 3, 5, 8. And so we were adding together the previous two numbers to get to the next number. Okay, so that was our Fibonacci. Cool. Then I'm seeing some other ones here. We have triangular numbers. Can anyone tell me what that triangular number sequence looked like? What were those numbers? Or if we can't remember them, how could we draw them out to figure out what they were?
1, 3, 6, 10, 15, 21.
Beautiful. Okay. Do you remember how we found those?
We used these dots to help us indicate. Yeah.
We did. We used dots to draw little triangles.
We used those triangle dots.
Good.
Yeah.
Okay. What was another way that we could find the numbers without the dots? It was sneaky. Let's see if anyone remembers. Think about differences.
It was minusing. It was like if you minus this, it's like, what is it? You find the difference between the two numbers and see how much the difference is. Like you go 3 minus 1, that would be 2.
Good.
So difference of 2. Then you go like 6 minus 3, it would be a difference of 3. And then 10 minus 6, which would be a difference of 4, and then you'd keep going on. Then
good. Good, nice. Okay, so that's our triangular numbers. Cool. Okay, and then I'm not going to go over all of them. We're just going to quickly look at square numbers and cube numbers, but I see you also have here tetrahedral numbers, which is awesome. We definitely spoke about them. And remember, that's like the 3D triangle type thing. And we spoke about doubling sequences. So well done for all of those. And then let's just quickly go over the ones which will come up the most often in tests. Your square numbers. What are my first few square numbers?
1,
4. Yeah.
9.
Yes.
16. 25.
There we go. Nice job, guys. Okay, so remember, it's just the number squared. So that would be 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. And then our other important one that often comes up in tests is our cube numbers. What are our first few cube numbers?
1. 8.
Good.
27.
Yes.
64.
Good.
125.
Excellent. Let's stop there for the moment. Okay, cool. So those were some of the sort of special number sequences that we spoke about. And then we were looking at number sequences where there was a constant difference between each of them. And we had to find what the next two numbers would be. So I would like you guys to give A and B a try for me and tell me if you can figure out what the next two numbers would be. And when you have an answer, I'd love it if you could put it in the chat for me. So just write your answer in the chat. And if you're struggling because you don't know how to write a fraction, you can just write the number with a line like that. So that would be 3. Oh, sorry, I've just sent some Beware a direct message with that answer. So 3/5 like that. So that's how you would show me a fraction. So when you have an answer for A, and well, even if you just start with A, I want to know what my next two numbers are going to be in this pattern. And when you've got an answer, put them in the chat for me. And we will keep moving. Don't overthink it too much. Okay, so we've got our first answers coming in for A. Keep them coming. Write whatever you think the first two answers would be for A. And remember, it doesn't matter if it's right or wrong. We're going to go through them anyway. So just write what you think the answers would be. Okay. Okay, so question A, it looks nasty. Don't worry, I won't do B just yet. I know not everyone's there. Question A looks nasty because at the top we're seeing 113, and then at the bottom we're seeing 424. And our go-to with fractions when we're dealing with patterns is try and get everything to have the same denominator. Okay, so for example, let's make everything have a denominator of 4. And that would be 1 over 4. And this would be 2 over 4. And then this would be 3 over 4. And so then that should make it a little bit easier. So then what would be my next number? In this case, it would be 4 over 4, or we could write it as 1. So if you wrote 1, that's absolutely fine. But 4 over 4 would be great. So 4 over 4 or 1 is 100%. And then our next one, great. Our next one, we would be wanting to add another one. So we're going to make it 5 over 4.
Also, you just turn on 6, okay.
Exactly. We're just adding 1/4 each time. That's all we're doing, is every time we are adding a quarter. And when we get to 5 over 4, you could write it as 5 over 4, or you could write it as 1 and 1 over 4, whichever one you prefer. But remember, in high school, we really like improper fractions. So you can always do an improper fraction when you're in high school. Okay, so now with that in mind, I want you to give B a try, and I want you to think of trying to use that method that we've just used now of getting everything to have the same denominator, and see if that helps you find the next two numbers. And then write them in the chat for me. Just keep the answers coming. Doesn't matter if they're right or wrong. Cool. Okay, so my first mission here is I want to make everything have the same denominator. Okay, so I'm going to say, I'm going to use a denominator of 5. So I'm going to say, well, I've got 1 over 5, then I've got 2 over 5, then I've got 3 over 5, and then I have 4 over 5, which means my next number would be 5 over 5, or 1, and my next number would be 6 over 5. Or
is this an example?
This is one of the answers.
Oh, okay.
But you didn't have to make them all over 5. If you wanted to rather put them all over 20 or over 10, you could have. So another way of writing that is we could have said, well, that's 4 over 20. That's going to be 8 over 20. That's going to be 12 over 20. That's 16 over 20. And so now if I'm working in 20s, I'm adding 4 over 20 each time, which means my next number would be 20 over 20. And 20 over 20 is exactly the same as 5 over 5 because they both equal 1. And then my next number would be 24 over 20, which would simplify down to 6 over 5. So those are exactly the same. So it doesn't matter which one you use, you would get to the right answers regardless. The most important thing to take away from this is when we're dealing with fractions, try and get them to have a common denominator so that we can see what the constant difference is. Okay. Okay, so that's just a quick recap of what we did on Tuesday. We are going to move on to looking at different patterns today and finding how to find the rule for it. So I know some of you have done patterns in class already. Who have done finding the rule? So like where you have to look at different things and say y equals.
I just covered that today.
You just did it today. Okay, that's awesome. And how did you find it in class?
Today.
Where's my book? So basically, it was a whole process.
Okay. It was a whole
so
process. It is.
We had to solve for A and also for B.
Okay, well, we are going to be doing that today.
We solved for Y, and it was the teacher explained it fast. So
okay. So some of you have already done this in class, so hopefully this will like be a nice cementer for everyone and it will bring us together. Okay, if you have it, the nth term we're going to do together next week. So we're going to do that on Tuesday and Thursday. Cool. Okay, so let's jump into finding the rule. So to get started, we're just going to sort of briefly talk about how processes work. And this is called a spider diagram. Spider diagram is just a fancy way of following a mathematical process. Lots of you would have done this in junior school. We're going to be taking it a step up from junior school. So a spider diagram is saying that if I have a number, this is my input over here. Can you all see the yellow? Is it dark enough? If it's not dark enough for someone, let me know. I know you guys would let me know if it was a problem. Someone would let me know. Thomas will let me know. Okay, so if my input is -1, I'm saying -1 times 2, which would give me -2, and -2 plus 1 would give me an output of -1. So we have an input and we have an output. So let's have a look at our next number. If I have an input of 0, it would be 0 times 2, which would be 0, and 0 plus 1 is 1. Let's have a look at your next one. Now we've got 3 times 2, which would give us 6, and 6 plus 1 is going to give us 7. So how would I write this whole situation of what's happening to x without a number? So now I can't say like 1, -1 or 7. It's going to have something to do with x. Can someone tell me what they think I could write over here?
Yes. Can I share this? You're gonna put the -1 there. You're gonna put a 2 in brackets. And you're gonna say +1.
Okay, so I'm definitely going to have a 2 and I'm going to have my +1. I really liked what you said there. And I liked how you had the 2 in brackets because you knew that we were multiplying by 2, which is great. Okay, but we're not going to involve this -1 because he's his own self. But what we've got happening in the chat here, I see some people have written, that's beautiful. We're taking x, which is our input. We are multiplying it by 2. Okay, and when we have x multiplied by 2, that gives us 2x. And then we are adding 1. And so if I wanted to write a rule for the spider diagram, I would say y is equal to 2x plus 1. And then I can put whatever x value I want in there and I would get an output. So in this case, y is my output and x is my input. Okay, and we're not allowed to add those from there. So now I can't say that that's equal to 3x. Can someone tell me why I'm not allowed to add those? Why am I not allowed to say?
You can't
Why?
add a number to, you can't add, what is it, 2x with a normal number.
Okay, but
Or
why?
anything. It doesn't go together.
Sorry, because they are not like terms.
They're not like terms. They are not like terms. Okay, so we can only add things that are like terms, and 2x and a constant are not like terms, so we are not allowed to add them. So that would be where we stop. Okay, let's try another one. So here my input, I'm going to put as -1. So I've got -1 times 3, which is -3. And then -3 minus 4 is going to give me -7. Okay, 2 times 3 is 6. 6 minus 4 is 2. 5 times 3 is 15. 15 minus 4 is 11. What is this output going to be?
3x minus 4.
Yes, glorious. Okay, it is going to be 3x because I'm taking x, I'm multiplying it by 3, and then I am subtracting 4. So my output is y, my input is x, y is equal to 3x minus 4. Okay, are we happy so far? We're just dipping our toes into the pool. We haven't done any swimming yet. Okay. I don't want you to worry about these ones just yet.
Those are the hard ones for me. Yeah.
I want you to tell me what this output would be with x.
Negative 2x. Oh,
2x plus 3.
There we go. I'm hearing good things. Negative 2x plus 2. Okay, so we're multiplying the x by negative 2, and then we are adding 2. So my rule here would be negative 2x plus 2.
2.
Good. Okay, one last spider diagram, and then we're going to go back to the puzzle from Tuesday, which Simpiwe has solved. So we have at least one person who solved it so far, and then we're going to move on to being able to find this rule ourselves. Okay. So again, I want you to be able to tell me this rule. If my input is x, what would my output be if it's y?
X
minus
2.
Great, guys. You're all saying it beautifully. My y would be 4x minus 2. So in question C, we were able to get rid of the bracket because it was just they were putting that bracket there to help us see that it was a negative sign. So you didn't really need to have it. If we were looking at the numbers, that's the same as saying -1 times -2. So we could also have written it like that, which would have been +2. And then +2 plus 2 gives us 4. Okay, guys, just remember to keep yourselves on mute, please, just so there isn't background noise happening. Okay, so we're going to quickly zoom back to our puzzle. Oh, sorry, I see I have a question. No? Okay. We're going to zoom back to our puzzle from Tuesday, see if anyone else has got the answer, and then we're going to move into being able to find this rule ourselves when we're just looking at a pattern. Okay. So this was your puzzle from Tuesday, and I was looking for what my question mark was going to be.
Ma'am,
Yes.
is the answer 39?
The answer is 100% 39.
Yes.
Nice. Did anyone else land up getting that when they were staring at this over the last couple of days? No. Okay. Well, let's try and break it up sort of step by step. Let's see where everyone went right and where people went wrong. So what was that crown with the red ruby? What did people get for
8.
that? Okay. Okay, so we know the crown and the red ruby was 8. Cool. Which means we know that that's 8, and we know that that's 8. Oh, 49, just 10 off, Sarah Jade. So if our crown with the ruby is 8, and this is 22, then what would our ring with the blue gem be?
6.
6. 22 minus 8 gives me 14. So these must be 7 each. Okay, so we know that our ring with the blue gem is going to be 7, and our crown with the red gem is going to be 8. So that means that this is 7 over here. Okay, so now if that's 7, now I'm going to say 19 minus 7. It's going to give me 12. So what does that make those? Okay, good. 6 and 6. Good. But that means that each ruby, so if this is 6 and this is 6, that means that each ruby is 3. Okay, so just keep that in mind. All right. Now we move on to our next step. So did anyone land up getting to this point here that we're at so far and didn't get the right answer? Okay. Okay, so we have a couple of people. That's good. That means you made most of the progress. Okay, so let's keep on going then. So now we know that this is 8, which means that this must be 4, and this must be, oh, let me write it at the top like I did for the others. So 4 and 4. So that means my rubies are 2 and 2. Okay. And now we just need to start putting everything in place. So this is where it got nasty. This is why I was trying to say that I was trying to trick you, because I was trying to trick you. This crown up here is a crown with a red ruby. And this crown is a crown with a blue ruby. So if I want to know what the value of just a crown is, I have to say my crown with the red ruby, which was 8, and then I have to minus what one of my red rubies are, which is 2, which means my crown, oh, sorry guys, my crown is 6. Okay. And so if I'm looking down here, I'm saying, well, this is a crown plus a blue ruby, and a crown is 6 and a blue ruby is 3, which means that that is 9, because it is a crown plus a blue ruby. Exactly, FODMAS. And then I've got a red ruby, which is 2, and a blue ruby, which is 3. And then I'm going to do the same thing I did with the ring with my crown over now. So I'm going to say my ring, which is 7, minus the blue ruby, which is 3, gives me 4. So my ring alone is 4. Sorry, guys. Which means that this is going to be 4 plus 3, which is 4 plus 2, which is 6. And so then it's going to be 5 times 6, which is 30, and 30 plus 9, which is 39. So well done to those of you who got it. I told you it was horribly hard. I did try and warn you. But like I told the new people on Tuesday, you have to blame your students who were here last term, because they moaned that my puzzles were not hard enough. So then I had to find a really hard one. So next week, what level are we going to look at if we have a scale of 1 to 10? So this is we'll call this a level 10. What number on that scale of a hardness of a puzzle would you like on Tuesday? 1, please. 1 will be too easy. Okay, I'm seeing lots of numbers between 5 and 7. So I'm thinking maybe we should go somewhere in the middle. But we'll do a picture one. 2. No, I'm not going to do 2. Avuyile? Do you have a question?
No, ma'am.
Okay, cool. Let's keep going. So now what we're going to do is we're going to try and put all of the stuff that we were speaking about, and we're going to make our own rule. So what I've got over here, well done to those of you who got that puzzle, by the way, I'm really proud of you. What we've got over here is we have got a table. Okay, and I'm going to go through this super slowly. And if at any point you don't understand, I need you to tell me. Okay, so just say in the chat, could you slow down? Can you go over that again? And then I will, because it's very important that you understand this concept. All right. So in this table, we've got some very important words. We have an input, which is our X, and an output, which is Y. Exactly the same we had in our spider diagram. We have an input, which was a number going in, and we have an output, which is what we get at the end. So if you think about the spider diagram that we just did, this 1 was our input. That would be our 1. And then our output, in this case, would be the 6. Okay, so we've put something in. We've done a whole sort of sum. We don't know what we're multiplying or adding by. And then we are getting an output of a number. And our job is to figure out what this formula is in the middle that took us from 1 to 6. Okay, so the first thing we're going to do is we're going to just complete this table up to here. So we're wanting to look for something called the constant difference. So I'm going to write that down over here. It's an important word, the constant difference. And the constant difference is just when we take one term and we subtract the term before it. Okay, so kind of like we did with our fractions right in the beginning of this lesson. And if you notice, each time 9 minus 6 is 3. So every time, I'm seeing it coming into the chat, which is great. Every time what we are doing is we are adding 3. So that is what our constant difference is. Okay, so then what would be my terms for 5, 6, and 7?
18, 21, 24, 21.
Beautiful. 18, 21, 24. Glorious. Okay, so that's our first part. We've done the first part of the question, which is great. Now we need to try and figure out this bottom part of the question. And in order to find out the bottom part, they are wanting us to write a formula. So they are wanting us to write y is equal to something plus or minus something. Okay. Now, in order to find that something and that something, the first thing that we wanted to do is find our constant difference. So our constant difference becomes really, really important. So in our formula, we have y is equal to something x plus or minus something. And we are trying to find out what those somethings are. Okay. The constant difference is always going to be the thing we multiply by x. So in this case, our constant difference is 3. So it's going to be 3x. So whatever that constant difference is, it's going to be the number that we multiply by x. Or later on when we're dealing with t and an n. Okay. Now I need to think about what I'm plusing or minusing. So let's have a look at our input, because remember, in a spider diagram, we had that input, we multiplied it by something, and then we added something to get our output of 6. Okay, so far, we know that our input is 1, and we've multiplied it by 3. And 1 times 3 is 3. So what would I have to add to 3 to get 6? I would need to add 3. So 1 times 3 is 3. 3 plus 3 is 6. So I know that this little something that I'm going to put over here is a 3. And once we've figured out our rule, we want to check that it works for everything. So then we're going to go back to our table and we're going to make sure it works. So we're going to look at this one, for example. So my input is 2. That means my x value is 2. So 3 times 2 is 6. 6 plus 3 is 9. And we get our answer. Let's look at another one. Let's look at the 4 and 15. 3 times 4 is 12. 12 plus 3 is 15. We get our answer. I just see I have a question. Does the plus minus mean more or less? So plus minus can mean more or less, but I was also just meaning we either need to add something or we need to subtract something. Okay. And that is how we find our rule. So the first thing we want to do is we want to find our constant difference. Then we want to think, if we put our input into here, so if x was 1 and we said 3 times 1 is 3, what would we have to add or subtract to get to our output? And we land up with y is equal to 3x plus 3. For those of you who have never seen this before, I can imagine that this is a little bit intimidating. Please don't panic. We're going to do lots of them in the rest of this lesson. So stay calm. This is just an introduction. I promise it will get easier with the more practice you do. Yes. Okay, so the TN formula that you've learned, you absolutely can use that formula. You just need to be careful with what the question asks. So if the question asks you to give an answer in terms of y, then you would need to write it with x and y. And if they ask you the question with TN, you use TN. It's totally fine. Okay. All right. Let's try another one. We're going to keep it the same. Oh, good. I'm glad that you guys are not struggling with this. Okay. Let's have a look at this next one. Okay, don't panic if you're struggling. We're going to do lots of these examples. Okay, so we're going to have a look at this pattern. The first thing that I want everyone to do is I want you to find out what these two numbers are going to be. So I want you to tell me what those two numbers will be.
-8 and -10.
Good. Oh gosh, I'm in highlight mode. Let's get rid of that highlighter. So we're going to have -8 and we're going to have -10. Beautiful. Okay, so in that case, what is my constant difference?
-2.
-2. So every time I move, I am subtracting 2. Okay, so the first thing we did was we found those two numbers. Second thing we did is we found our constant difference. Okay, now I'm just going to draw the slide diagram for those of you who are still struggling with this concept, but I don't want you to panic. You don't ever have to draw this. I'm just doing this for those who would like it as help. Okay, remember this is your input and this is your output. Okay, I'm going to use my first number as an example of my input. So my input is 1. We know that we are going to multiply it by our constant difference. We always are going to do that. Yeah.
Ma'am, sorry to bother you, but I see in the chat a lot of people are struggling with the one they taught us in class, the TN one. So I wanted to ask next lesson, if you find the time, can you please revise over that one?
The whole of next week, we're going to be doing TN.
Thank you, ma'am.
Sure. So next week, Tuesday, and next week, Thursday, we're only focusing on TN. So don't stress. Okay. Okay, so if my input is 1, the first thing I need to do is I'm multiplying it by my constant difference, which is -2. And I want to get an output of 0. So I'm saying 1 times -2 is -2. How do I get to 0 from -2? So I am on -2 and I want to get to 0. What do I have to add to get to 0 from -2?
Add 2.
Yes, good. I need to add 2. So I'm going to have 1 times 2 is -2. -2 plus 2 would give me 0. And just through doing that and drawing our little spider diagram, we have figured out the rule. Okay, so our rule is going to be y is equal to -2x. Remember, this is always, always, always your constant difference. And then I'm going to say plus 2 because that's what we needed to get to our output. So just as a reminder, this number being multiplied by x is always going to be your constant difference. And then we look at our input and our output and we say, if my input was 1, I would say -2 times 1, which is -2, and my output is 0. How do I get to 0 from -2? I need to add 2. Okay, let's finish off this table then. So now I want to know what the answer is going to be under that 10 over there.
-20.
-20.
18.
-18. Because we're going to say -2 times 10, which is -20, plus 2, which is -18. Okay. And then my formula for x is going to be y is equal to -2x plus 2. Okay, let's try another one. Okay, give this one a go, especially if you're struggling. I'd really like you to give this a try and see how you go, see how far you get in the process so that you can let me know where you're needing help from. Your first goal is to find out what these 3 numbers are going to be. Your second goal is to find your constant difference. And then your third goal is to get the formula. And let me know if you're needing help along the way, or let Nicole know if you need help. Remember, she's there to help you. You just send a message whenever you need help. That's what we're here for. I'm just going to let you guys work for a little bit, and then we're going to go through all of these together, and we're going to see how people did.
It's 357.
It is. I'm just going to wait a little bit longer to give everyone a chance. Once you've found those numbers, remember, look for your constant difference and then try and figure out your formula. And you're welcome to write it in the chat for me. We're just going to try and give everyone a chance to get there. Hi.
Is the constant difference plus 2 now?
The constant difference is definitely plus 2. Nice job, guys. Okay, so far you've seen that that needs to be 357, and you've seen that your constant difference is +2. So that's really good. Okay. Now, if you're still struggling, I want you to think about your spider diagram. Your output would be -5. Your input would be 1. And so that should help you figure out what's going to go in that box over there. Good, +2 to get to the next number, good.
Ma'am,
Yeah,
can I ask that should we always start with the input and times that with?
the constant difference.
Yes.
Yes,
Ma'am, y
always.
equals 1 times 2 plus 3.
Oh, we wouldn't have a +3 in this one.
What if ma'am 1 times 2 minus 7?
Yes, there we go. Okay, so when we're working through this, we would say, well, 1 times 2 is going to give me 2, and I'm trying to get an answer of -5. So I need to minus 7 from that. And once we've done that, then we've actually figured out our formula. So our formula is y is equal to 2x minus 7. And then if we're wanting to find the number for 10, we'd say 2 times 10, which is 20, 20 minus 7, which is 14. Okay, so tell me where we are at on a scale of 0 to 10. 10 means we're understanding this perfectly and we're doing really well. 0 means we have no idea what's going on. Tell me where we're at. Okay. Okay, if you're really, really struggling, remember you're also welcome to send Nicole a message and she will happily help you. She will happily go through it with you sort of in the chats. So don't stress. Okay, that's what she's also here to help with. It's okay if you've done it a different way at school. The way we're going to look at it on Tuesday and Thursday will also be a little bit different to this, but it's just different ways of doing the same thing. So don't stress, to whichever way you feel comfortable with. Okay. So this looks like it's different, but it's not, okay? It's exactly the same. It's just we're looking at things a little bit differently. So we're going to sort of take it, taking some of the things that we've already done, and we're going to add a little bit extra. The first thing that I want you to all do is I just want you to tell me what this number in that square is going to be.
6.
Yes, good. Okay, good. And how do we know that it's 6? What is our constant difference?
+2.
2. Okay, good. Okay, so remember the first thing we wanted to do was we want to find our constant difference. And once we have found our constant difference, we have y is equal to whatever our constant difference is times x. That's our first part of our formula. And then we either are going to have to plus or minus something to get to our output. So we're going to have a look at our first setup over here. Our input is 1 and our output is 0. Okay, so that's saying that x is 1 and we know that y is going to be 0. Okay, so I'm saying, well, if x is 1, that's going to be 2 times 1, which is 2. And I want to get to 0. So how do I get to 0 from 2?
-2.
2. So I have to subtract 2. And remember, we can use now our formula to make sure that we've gotten everything correct. So we can look at our next one over here, for example. Our input is 2 and our output is 2. So if our input is 2, 2 times 2 is 4, 4 minus 2 is 2. We got it right. Let's look at our next one. Our input is 3. 2 times 3 is 6. 6 minus 2 is 4. We got it right. Okay, so that means that we know that for x, it's going to be y is equal to 2x minus 2. That is our formula. Okay. What is happening over here? What is A and what is 28? Is
A
A
is the input
good?
and 28 is the output. This is something similar to what we did at school.
Good, I'm glad. Okay, so A is our input and 28 is our output. Okay, and in our rules, is our output X or is our output Y? So think about that question again. Is our output, is the output X or is the output Y?
Y.
It's Y. Okay, our output is Y. And so from here, we know that our Y value is 28 and we're trying to find what our X value is. In this case, that X value is an A. Okay, so our Y value is 28 and we are trying to find what X is. And what we have is an equation. And I know we haven't done equations together, but we did equations in grade 8. So if I'm trying to find what X is, if this is an equation, I'm gonna write it over here so I have a bit more space to write. Who remembers what we do in an equation situation? What's like our main goal? What do we want to what do we want to do?
Solve.
Yeah, we want to solve for X. And in order to solve for X, we want to get the things that have X's on one side and we want to have things that have no X's on the other side.
Grouping like terms.
Exactly. We're going to be grouping those like terms. Okay. So what we want to do in this situation is we want to move this 2 to the other side of our equal sign. And when that 2 moves over, his sign changes. So it's going to be 28 plus 2, which is equal to 2x. This might be bringing back some memories from last year for some of you. Okay, so 28 plus 2 is 30. 30 is equal to 2x. And then we need to divide both of them by 2. And so x is equal to 15. So all we're doing is we're using an equation. Okay, now we haven't done equations for a long time, so I know that they may feel a little bit confusing. The most important thing is just get everything with x's on one side and numbers on the other side. Okay. I want you all to give B a try. So try and write the equation on your own, on your books, on your side, and see if you can solve what B would be. And I'll show you, if you're struggling with the equation, I'll show you how you can do this with the spider diagram as well. Okay, so my output is 116, and I've got 2x minus 2. So the first thing I'm going to do is say 116 plus 2 is equal to 2x. So that's 118 is equal to 2x, which means 59 is equal to x. Okay, if you are struggling with the idea of an equation, then the spider diagram is your friend. Okay, so remember spider diagram, we have an input and we have an output. We know we are multiplying by 2 and then we are subtracting 2 to get to our output. In a spider diagram, when you're working backwards, you do the opposite signs. So it's basically what we're doing in our equation, but just in a picture form. Okay, so our output is 116 and then we work our way backwards. So 116 plus 2, which is 118, divided by 2 is 59. So you can always use your spider diagram to help you if you're struggling with the equation just by itself. Okay. But don't panic. We're going to be picking up from this spot on Tuesday, and we're going to do a little bit of extra. Tiana, how can I help?
Babes, so I want to like add on to what Babe said there, but I just
Yeah.
found the easier way there. So I said, before Babe started with A and B, if Babe was still busy by X, and I said, 28 divided by, wait, what did I say also? I think I said something of 28 divided by 2 or something like it. And then I found it I got 14 and 58. And then I was just like, Babe just adding a 1 here because then I got confused. And then adding a 1 by each of them still got the same answer.
Yeah, no, you would. So through sort of feeling your way around and you knew that you were going to divide by 2 at some point. So you'll get to vaguely the right answers, and then you have to do a bit of trial and error. But just where we need to try, that's great. And I'm so glad you did it because you were engaging with the question. So I never want you to not ever sort of try things like that. But trial and error, it's so good. But we also need to learn ways so that we know we can always get to the answer straight away. So we don't have to waste time in a test. We know, okay, we know what to do and we can get it done.
Yes, Babe, thank you.
Okay. Okay, guys, so on Tuesday, we're going to take off from this point and then we're going to work on some TN stuff. But from now, because it's a Thursday, so for those of you who are new, you don't know this, but on Thursdays, you do a little quiz. So what I'm going to do from here is I'm going to hand you over to Nicole, and then Nicole's going to make sure you can all get the link in the chat, and she's going to help if any of you can't get onto the quiz. And if you have any sort of residual questions you want him to ask, she's going to help you answer them. And I'm going to move on to my grade 10s, and I will see you guys on Tuesday. Okay.